Hi, I am Professor Ajir. We are going to teach you the subject Basic Electrical and Electronics Engineering. First, we will learn the basic concepts of the electrical engineering. First, what is the difference between the conventional current and the electric current? We are considering one conductor. Suppose it is of copper having 29 is the atomic number. So, because of that, the one last orbit having one electron. So, conductor is the combination of atoms, therefore it is the combination of many electrons revolving or moving in any direction. When we are connecting one voltage source across the conductor, likewise having the voltage source V, then we all of you know that the electrons having the negative charge, therefore this negative charge electrons attracting towards the positive charge. Likewise, this is the direction of the electrons. So this direction of the electric current, we are calling it as actual direction of the current. It is the actual direction of the current, or we are calling it as electric current. It is electric current. But during solving the problems, we are considering the current direction is from positive terminal to the negative terminal, positive terminal to the negative terminal. Likewise, this direction during solving the problems we are considering. So this direction of the current, we are calling it as conventional. It is a conventional flow or a conventional current. This is the difference between the actual current or electric current or a conventional current. Resistance. What is the resistance? Resistance is the property of a substance that opposes the flow of electricity or a current through it. The resistance is indicated by R and the unit of a resistance is ohm. Then the symbolic representation of a resistance is like this. This is the symbolic representation of a resistance. Then the resistance depends upon, first one, length of the conductor. That means when the length increases, resistance increases. That means length and the resistance are directly proportional. Then it also depends upon cross-sectional area of a conductor. That means it is inversely proportional to the cross-sectional area. Resistance inversely proportional. Then it depends upon the nature of the conductor and also depends upon the temperature of the conductor. So depending upon the temperature coefficient, the resistance having two different types. First one is PTC. PTC means the positive temperature coefficient. That means when temperature increases, resistance also increases. Then the second one, NTC. NTC is nothing but negative temperature coefficient. When temperature increases, resistance decreases. Therefore, it is negative temperature coefficient. Now we will see the resistivity. What is resistivity? Suppose I am considering one cross-sectional area A, and the length of a conductor, length is the cross-sectional area of a conductor, then length of a conductor is L, then measure it is in meter, then the resistivity, how you are calculating the resistivity from this? Here we know the resistance is directly proportional to the length of the conductor. That means resistance is directly proportional to the, it is directly proportional to the length. Then cross-sectional area, it is inversely proportional to the cross-sectional area. That means the resistance is inversely proportional to the cross-sectional area. Then, therefore, the resistance is directly proportional to L upon A from these two equations. Therefore, R is equal to rho L upon A. Rho we are considering it is constant or resistivity. Rho is called as a resistivity. Therefore, resistivity is equal to R into A upon L. R A upon L. Now we will calculate we find out the unit for the resistivity. See here. We are measuring resistance in ohm. So resistance measured in ohm. Area measured in meter square, and the length in meter. So it is equal to m get cancelled. So ohm meter. This is the unit of a resistivity. Unit of a resistivity. The potential difference. Before learning the potential difference, we will learn the concept. What is electric potential? What is electric potential? We all of you know that the similar charged particles repel each other. Similar charged particles repel each other. Then dissimilar charged particles attracts each other. This means that every charged particle have a tendency to do work. So this ability of a charged particle to do work is called the electric potential. That means electric potential is equal to work done upon charge, having the ability to do work of a charge. Then now the potential difference. What is potential difference? Suppose I am considering the two electric potentials E1 and E2. These are the two electric potentials. Then potential difference is nothing but difference between these two electric potentials. Suppose having distance d, or we are not considering the distance. So therefore potential difference is equal to E1 minus E2 if E1 is at higher potential than E2, or E2 minus E1 if E2 is at higher potential than E1. This is the potential difference. Now we will see the current. What is current? Current is represented by I, and the unit of current is ampere. Here the unit of the electric potential is volt, and also for the potential difference it is volt, and the unit for the current is ampere. So current is simply the flow of electrons, the rate of flow of electrons. So I is equal to Q upon T, or a rate of flow of electrons or a charge particles per unit time. It is the current. Then now we will see the Ohm's law. What is Ohm's law? Suppose I am considering one conductor. This is one conductor. This is the conductor having resistance R, and current flowing through the conductor is I, and the potential difference across the conductor is V. Then V is, that means voltage is directly proportional to current I. Therefore it is V is equal to I into R. Here R we are considering it is constant. R is the constant, or a resistance. We are calling it as resistance. So V is equal to voltage. V is the voltage measured in volt. I is the current. I is the current measured in ampere. Then R is the resistance. R is the resistance measured in ohm. How we are simply remembering the Ohm's law like this. This is the voltage, current and resistance. See here it is V is equal to IR. That means V is equal to IR simply. V is equal to IR. Then I is equal to V upon R. I is equal to V upon R, and the R is equal to V upon I. This is the simple way to remember the Ohm's law. Now we will see the types of a voltage source. First one is the ideal voltage source and the practical voltage source. So what is ideal voltage source? See here in the circuit, Vs is the source voltage, VL is the load voltage appearing across load resistance RL. Then the IL is the load current flowing through the load resistance. So ideal voltage source is nothing but what is giving to the source, that means source voltage directly equals to load voltage. What is the source voltage? We are appearing directly across load voltage, not depends upon the current, load current. Current will be anything, but Vs is equal to VL in the ideal voltage source. See here, VL is equal to Vs, not depending upon the load current. This is the characteristics of the ideal voltage source. Then practical voltage source. Practically, in the source voltage having internal resistance, some internal resistance. See, RSC is the internal resistance of the source voltage, RL is the load resistance, VL is the load voltage, and the IL is the current flowing through the load resistance. So practically, see here, we are finding the voltage across the load resistance. So it is VL. VL is equal to, this voltage is equal to this total voltage, source voltage, minus the voltage drop across the internal resistance. So it is equal to Vs minus, it is voltage across the internal resistance. What is the internal resistance? Voltage across the internal resistance. According to Ohm's law, V is equal to IR. So across this resistance we are finding the voltage. So it will be current through the internal resistance is IL and the internal resistance is RSC. Therefore voltage across it is I into R. So I is IL and the resistance is RSE. So voltage across the load is Vs minus IL RSE. So here this is the ideal and this is the practical. So VL is equal to Vs minus IL RSE. Here the load voltage is not depending upon the load current, but here in the practically load voltage depends upon the current also and the source voltage. So Vs is equal to VL is equal to Vs minus IL RSE. This is the characteristics for the practical voltage source. Now we will see the current source. Current source also having the two types. It is ideal current source and the practical current source. So firstly, ideal current source. Here it is IS. IS is the source current, load resistance RL, voltage equals to the load resistance, it is VL, and the current through the load resistance, it is IL. In the ideal current source, which we are giving the source current, it appears through the load resistance RL, it is IL. Simply